Hello, welcome back to ArmanisMath. Today we're going to focus on how to solve quadratic equations. Here's a warm-up. Give yourself a couple of minutes. I'm going to put the timer here for you. You probably need about a good 3 minutes here. I'm going to pause in a few seconds, but when you watch this afterwards, make sure that you spend the time to do the warm-up. It is important. All right. Let's get started. If I'm asked to solve this equation here, I'm going to distribute the 6, and then this means I'm going to end up with give myself room here for me to do the problem. That's problem number 1. So 6x minus 6 plus 4 equals 7x plus 1. And I'm going to combine like terms. So the 6 and 4, this is 6x minus 2 equals 7x plus 1. Excuse me. I could subtract the 7x's from both sides, or the 6x's. I'd rather end up with I'd rather end up with positive x's. So I'm gonna subtract the negative 6x's here from both sides. Subtract 6x's from both sides will give me 1x plus 1. Subtract the 1 from both sides. I'll end up with x equals -3. Remember that when you find a solution, you need to plug it back to see if it's going to work. So I need to check -3. So I'll have to put it here. If I put -3 here, that will be a -3 minus 1. That's a -4. And 6 times -4 is -24 plus 4. That's -20 on the left side. And on the right side, 7 times -3 is 21. -21 plus 1 is -20. So that one would work. Okay. Make sure that you check the answer. Check your answer. All right. Number 2. We're asked to multiply here. So basically you have a binomial, 2 terms, 2 items times 2 items. There's obviously a shortcut for this one, which we will be introducing later on, but now that's the best way to do it. There's multiple ways you could multiply, one of which is to FOIL. Not a big fan of FOIL since it is pretty limited to only 2 by 2 items. You could also distribute, take one parenthesis and distribute out, or you also could do the box, which is my favorite method. Okay, so I'm going to do the box with you here. And to do the box, I basically need to draw myself a box. And the good thing about the box is expandable. So it's not limited to 2 by 2. You could have 4 by 4, 5 by 5. You could have 2 by 6, whatever the need might be. That's why I'm a big fan of the box. And on top of that, you actually see a visual multiplication of what you're doing. X times x is x squared. That's a 2xy. Another 2xy. And that's a 4y squared, I should say. Now, once you do more of these, you're able to collect like terms within the box, but until then, I would highly suggest that you list them again. So again, it's x squared plus 2xy, another 2xy, plus 4y squared. Now I would collect like terms, so this is x squared plus 4xy. There's a y here. There's a y here. Plus 4y squared. That is the answer for that one. All right. So once, as I said, you have multiple ways to multiply, one of which is FOIL. But again, the limitation of FOIL, it's only a 2 by 2. If you go beyond 2 by 2, FOIL disappoints you. You don't want to have that to happen, right? So that's why the other methods would work, distribution or the box. That's one of them. Obviously, there's more. There's actually a shortcut for this, but we're not going to talk about it today. Number 3. Number 3 would be the number 3 would be the square root of 80. And you will need to find a perfect square, the largest perfect square under the 80. So you were thinking of the 4s, the 9s, the 16s, the 25s, etc., etc. So I know this is going to be a 16 times 5. Also, you could divide by 2s also. That's another way to do it, which is 16 times square root of 5. And square root of 16 is 4, square root of 5. So that's the final answer is 4 square root of 5 for number 3. That was number 3. Okay, let's do number 4. For number 4, I have to simplify. I probably do not need this much area for work because it's pretty obvious. To simplify this, I'm going to divide by 2. Divide by 2. That's going to give me 2 square root of 3 over, I'm sorry, this is a 3 here. 2 square root of 3 over 3. Now a biggie for this one, this is the answer, by the way. I cannot simplify this further. But some might think that, hey, come on, these guys look alike. Why cannot I just simplify them like that? Oh, that's a no. These are not the same. Square root of 3 is not the same as 3. The square root of 3 is between the square root of 2 over square root of 1 and the square root of 4, which is between 1 and 2. This is 3. That's way beyond that. So please do not do that. Here's the objective. I will be able to solve quadratic equations algebraically using 4 methods. Factoring. That's too fast here. Factoring. Extracting square roots, completing the square, and the quadratic formula. So when you're reading this, if you're in the chat or in the comments, make sure that you pick a word from the objective and put it there. Four different ways. 4 different ways to solve quadratic equations, one of which is factoring, extracting the square root, or sometimes just named square root, completing the square, and then quadratic formula. Where in the whole world do we use this one? Well, you use quadratic equations applications and calculations. For example, quadratic equations calculations are used in missile and rockets launching missions. You want to see how far and how high can the rocket reach. If you could think of another example, share that with us in the comments. or in the chat. Here's the form of the quadratic equation. This is one of the forms of the quadratic equation. A quadratic equation in x is written in the form of ax squared. Please pay attention that the coefficient here, a is next to the x squared. The coefficient b is next to the x, and then plus c. C is the constant. Where a and b and c are real numbers, with a does not equal to 0, because if a is 0, that means it's not quadratic anymore, it will be a linear. Okay, so just keep that in mind. The b is right next to the x. The b is the coefficient of the x. There's another thing that I want to talk about, what's called the zero product property. The zero factor property, or zero product property. It says if a and b are real numbers, then a times b equals 0. If a times b equals 0, then a equals 0 or b equals 0. What does this mean? Well, we're going to take a look in a second. For example, if I said, let's do something like that here. So x plus 2 and x here equals 0. If that's what you're saying, then it's x plus 2 equals 0, or x by itself equals 0. And obviously here it's subtract 2, so x equals negative 2. So either one of them is 0, and that's what the zero factor property is. This one could be 0, or this one could be 0. If you multiply, then either of them either one could be 0. So let's start the work here. We're going to start solving quadratic by factoring. Okay, going to solve by factoring, and there's multiple ways, obviously, depending on the needs here. But in this case here, I could see that I'm looking at things that look alike, things that I could factor out. For example, if I'm looking at the 4 and the 24, they have something in common. I'm thinking of the 4 as something common, so I could pull that as a common factor. I also am looking at the other one, which is the x squared and the x, and I could tell that they have something common, which is the x, so I'm going to pull that outside as well. Then I'm going to open a parentheses for myself, just like that. And now I'm going to take the first term, which is 4x squared, divided by my common factor. So in my mind, I have just usually have a little area here for me to doodle, just me. And I'm going to talk to myself here and say, you know what? This is 4x squared divided by the common factor, which is 4x. And 4's are gone. X times x divided by x squared, just the x. Well, I'm left out with just the x. And that's what you have here. Minus 24x. I've got 24x divided by 4x's. Okay, 24 divided by 4. 4 times 6 is 24. So that goes into it 6 times. I know that I have a 6 here. And the x's are going to cancel, leaving you with just a 6. So 6. And obviously, if you're solving here, that means this is an equation which will be equal to 0. Don't forget that, so it's going to be 0. Now go back to the zero product property that we talked about. So it's either this amount on the left is going to equal to 0, or this amount on the right is going to equal to 0 before the equal sign. So basically, you're going to have to do something like that. 4x equals 0, or, and you could say the word or, that's okay, or x minus 6 equals 0. And you could divide by 4, and x is going to be equal to 0 here, because 0 over 4 is 0. And you could add 6, which will give you x equals 6. Two different solutions for this quadratic. By the way, I need to mention that the exponent or the power determines the number of solutions. So for example, if you are talking about a quadratic second degree, that means you expected to see 2 solutions. So this is not foreign to me. I'm expected to see 2 solutions. Now, they could be real solutions, both of them. They could be imaginary solutions, but I'm expecting to see two solutions. If it's linear, then I only expect to see one solution that is touching the x-axis. All right, champions, here we go. Nice and neat. Example number 2. Solve the quadratic equation by factor. What makes it quadratic? Well, it's the second degree here. This is the exponent. That's what makes it quadratic. If it's exponent of 1, that's linear. Now this one is quadratic. So there is, again, multiple ways to do this one. But obviously, remember that you have to put that equal to 0 because you are solving. Now the biggie here is the choice that you're making when you solve this. So some people have trial errors. They put 2 columns and then they try this and that. But I'm going to show you one method that it's been kind of really liked by many, including teachers, and it's called the diamond. Well, it's just like this shape here, maybe, or something close to that. Diamond, and it's not actually a diamond. It's just a big, large X. So it looks like this, a big large X that looks like this. And before I do the fill in this big X or the diamond, we don't call it X because we have a lot of X's in algebra, so just call it the diamond or the star if you'd like. Now this big X here needs to be filled out by looking at the coefficients, the numbers next to. So here next to the x squared there's an a. Do you guys remember that slide? There's an a here. So I know there's an a. So a equals 1. Obviously there's nothing here, that means there's 1. B is the coefficient of the x, which is the number here next to the x. Well, it's just a 1. C is the constant by itself, which is in this case -6. Okay? And I'm gonna perhaps give myself more room here. I need to expand this just a little bit. I'm actually gonna take it and put it right here. So what goes at the top of this diamond is A times C. So if you're with me and I wanted you to take your index, perhaps if you're in a room where there's an air conditioning at the top, AC, just point at the top with your index. That's where the AC goes, okay? The AC goes at the top. The B, or the bottom, or the basement, is always at the bottom. B, basement, always at the bottom. And then what you're gonna do here in this diamond thing is you're gonna find 2 numbers here, 2 numbers. When you multiply them, it gives you the top because it's A times C, it's AC. When you add them, it gives you the bottom. So what are these 2 numbers? Well, let's take a look. A times C, I have a 1 times -6. So what's going to go at the top here is going to be a -6. How about the B? Well, the B is the basement. Whatever that number is going to be at the bottom here. That's 1. So now your brain is going, what are 2 numbers? What are the 2 numbers that when you multiply them, you're going to get -6. And when you add them, you're going to get 1. Okay, so you try 2 numbers, like 2 and 3, for example. If I put 2 and 3, 2 times 3 is 6, not -6. That's not going to work. I'm close, so probably I could play with the sign, whether negative or positive. So, what if I put -2? So -2, that's going to give me the top. That's correct. -2 times 3 is -6. That's correct. A happy face for that thing. And what about -2 plus 3, or 3 minus 2? That's 1. Oh, that works for the bottom as well. Interesting. So I would like to see these numbers here. Once you get the numbers that multiply gives you the top value, and you add gives you the bottom, then you pause. And then you circle your answer. Okay, so you're going to have to circle that answer. So I'm going to just do it like this here. See that? Just like this. And I'm going to come here and say, do the following. I'm going to say, okay, 1 second. I'm going to say that this is my 2 factors now. X minus the 2 x plus the 3, and both of them have to be equal to 0. And from there I'm going to split, just like I did in the last problem, where I did the OR. Remember that OR? So I've got x minus 2 equals 0, or x plus 3 equals 0. And I just add x to 2 to both sides. X equals 2. That's one solution. X equals negative 3. That's another solution. Excuse me. So now I have two proposed solutions for this quadratic equations. Now you might want to try them, right? Plug them back and see. For example, if I put 2 here, that's going to give me 4 plus 2, that's 6 minus 6 is going to give me 0. That's correct. That would work. So if when I check this guy works. What if I check the negative 3? Negative 3 squared is 9. Minus 3. 9 minus 3 is 6. Right? 6 minus 6 is going to be 0. That works as well. So both of these values actually work. Both of these are solutions. By the way, do you know what exactly this means? Because when you say these are solutions, if you say these are solutions, what you're saying is this is a quadratic equation, quadratic graph that touches the x-axis at these two numbers. It touches them at 2, and it touches at negative 3. That's what you're saying. Because solutions are roots, are x-intercepts, are zeros of the function. So that's what you're saying. When you solve, you're saying that you have real numbers. You're physically touching the x-axis at these two locations. All right. So what I did for this method again is did something called the diamond or the big star, in which I have to label my coefficients. The a, which is next to the x squared, the b, which is next to the x, and then the c, which is the constant. I did myself a diamond. AC is at the top, just like air conditioning is at the top. B is the basement at the bottom, and I just multiply a times c. Well, whatever my a value is, that's 1 times c is negative 6. So that's what I put at the top. Divide that by put the b at the bottom, and then figure out two numbers to get you there. Once I'm there, I'm going to put myself that into factors form, and then from there I'm going to solve each one of them. Once I finish, I have to check it back. All right, guys, that's awesome. Here it is, printed format. All right. How about this one here? This one is similar to the last one with minor exception. So it says solve by factoring. However, I don't see 1 as my coefficient of the x squared. The a is not 1 here. So when the a is not 1, there's one more trick that you need to do. One more step, that is. Okay? I'm going to talk about that in a second. Same thing. I'm going to use a diamond. Okay? And before I do that, I just have to label my coefficient. So this is a. Let me use a different color for that. So a equals what? Can somebody tell me? It's not 1 anymore. A equals 4, right? That's a cute a there. And b equals, remember, when you take the coefficient, you take it with its sign. So b is negative 12. And c by itself is just the 9. So I have to know, remember that song? Now I know my ABC. Next time, won't you sing with me? Okay, you got to know the ABC. Now, once I do that, I'm going to go and do the diamond. So I'm going to diamond this here. And I diamond, once again, you put AC at the top, that's the air conditioning at the top, and the B, the basement. So what's 8 times C? I've got 4 times 9. 4 times 9 is how much? Should I pause a second? 4 times 9. Hello. 30. 4 times 9. 36. And the b is negative 12, so I'm going to put negative 12 here. Now remember, you got to find two numbers, multiply, give you 36. Same numbers give you negative 6 when you add them. So what are the two numbers? Well, you try things. I'm going to try 6 and 6. Maybe that's going to work. 6 and 6, 6 times 6 is going to give you 36. But 6 plus 6 is not going to give you negative 12. So that means you have to play with the signs. Maybe it's negative 6. Well, negative 6 times 6 is negative 36. That's not going to work. So maybe it's negative 6, negative 6. Oh, okay. Oh, that works. Because negative 6 times negative 6 is positive 36. And negative 6 minus 6 is negative 12. So it's going to work for both of them. So got a happy face here. That works. And a happy face down here. That means it is working. Now, since it's working, there's one more step, though. If your a is 1, you're ready to circle and go and do your wonders. But, and there's a big but here, a is not 1. So if a is not 1, all what you have to do is just divide by that a. So I'm going to divide by the a. When I divide by a, obviously if you can simplify, do it. If you could end up with a whole number, do it. Whatever you're going to get. So this one, if I divide this by a, obviously this is a negative 3 over 2. That's the value. And a duplicate value of it is here, negative 3 over 2. These are the things, these are the two values that I have to circle. Okay? These are the values that I circle. Just like that. And I'm going to come here and say, well, you know what, Armani? I've got x minus 3 over 2. X minus 3 over 2. And that's going to be equal to 0. Well, back to square one. You're going to say either this or that. So I'm going to say x minus 3 over 2 equals 0. Which, if you actually do it, you'll end up with x equals 3 over 2. That's one solution. The other one is, well, believe it or not, it's the duplicate of that one, which means x equals 3 over 2. So the truth about being a second degree is fulfilled here. Yes, it's a duplicate, right? It's a duplicate solution, but you still have two solutions. So these are sometimes referred to in math as multiplicity. You have a solution that is like repeated. So obviously you're going to say the solution is just x equals 3 over 2. You don't want to repeat it twice. But down the road, we're going to label these. Why do you have 2? And if that, for example, is crossing the x-axis or barely kissing and leaving the x-axis. But for us now, this is just going to be one solution that is repeated twice, because I have to have two solutions. This is quadratic. The second degree means I'm expecting to see two solutions. It could be one that is repeated, which is in case here. It could be two separate ones like the previous problems, or it could be two non-real ones, which means the quadratic is not even touching the x-axis. All right. Okay, here we go. Now this one's solved by the square root. So we're going to solve quadratic by the square root. What does that mean? Well, let's take a look. We got this problem here. 4x squared equals 12. All right. I obviously to get rid of the 4, which is going to square equals 12 over 4 is 3. This is x squared equals 3. Well, what is x by itself? Well, x by itself is going to be plus and minus square root of that 3. So basically what you're saying, there's There's also two solutions here, right? That's not new to me. It's not news. Because once again, this is quadratic, second degree. I'm expecting two solutions. Well, here they are, two solutions. Either square root of 3 or negative square root of 3. Two different solutions. Okay. The second one here. This one says I have x minus 2 squared equals 5. And if you recall, you have the ability to take the square root of both sides here. So I'm going to take the square root of this, and obviously the square root of that. If you take the square root of something being squared, you're going to end up with just what's under that, meaning x minus 2 is going to be the result here, equals plus and minus square root of 5. There's two values for the square root. Okay, and then you're going to add the x to both. You're going to add. You're going to add the 2 to both sides. And usually you start with the number and then the radical. So x is going to be 2 plus and minus square root of 5. Basically, there's two solutions here, by the way. That's two of them. There's 2 plus square root of 5, or 2 minus square root of 5. And both should be counted for. Both should be accounted for, okay? Not just one of them. Why is that? Well, because you have a second degree function here. All right. All right. Another method for solving quadratic equations is completing the square. You complete the square. And here is the theory behind it. It says to solve x squared plus bx equals c by completing the square, add b. Remember, the b is next to the x, right? Where b is the coefficient of the x. Take that b, whatever that number is, divide that by 2, and then square it, square that fraction. And then add that to both sides of the equation. Doesn't look too hard, by the way. It could be just cumbersome if you're not a fraction freak, but it's just, once again, you're taking the coefficient of the b. I should say the coefficient of the x, which is the b, divide that by 2, and then square that and add it to both sides of the equation. I want to point out again, I just want to emphasize that we're talking about this b here, and the b is the coefficient of the x, not the x squared. It's the coefficient of the x, whatever is next to the x. And I refer this method by saying something like the bucket. What I'm referring to at the moment now is this. So have this in your brain as your bx, and I leave myself room, and I have c here, and that's what I do. Okay, I add a bucket. I'm not going to use that color. So I'm going to add a bucket here. You add a bucket on this side, and then you add the same bucket to the other side, plus a bucket. So how do you fill this bucket? You get the b, divide that by 2, and square it. We're going to do the same thing on the other side, obviously. b over 2, square that. And that's how you complete the square. You're completing the square by taking the b factor, divide that by 2, square it, put that in the bucket here, and also on the bucket on the other side. So let's take an example of that. Solve the quadratic equation by completing the square. So what's given here? Well, I see x squared minus 6x plus 2. And sometimes when you try to solve by factoring, or by, for example, the diamond that I showed you, it would not work. It wouldn't work. That's why you're trying something like this here. So in this case, I gotta get rid of the c by subtracting the c on the other side. I basically wanted the x squared and the x by itself on one side, and then leaving the constant on the other side. So I'm going to subtract that from both sides. Basically, I'm going to end up with x squared minus 6x. Don't forget the bucket, and I'm going to put the negative 2 here. So basically, all I'm going to do here is now add this bucket plus a bucket here, plus a bucket. So how do you fill this bucket? Well, we just said, remember, you take the b. What is the b? Or where is the b? It's this guy here. The b is the coefficient or the number next to the x. That's the b. You're going to take that b, which is -6. I'm actually like to doodle things on the right here instead of making things cluttered. So I'm going to go here and deal with my b on the side here. So that's going to be -6. That's the b, right? Let me write it down for you. b over 2 squared. That's the one that I'm going to fill in the bucket with. So -6 over 2 quantity squared. Well, what's that? Well, this is 36 over 4, isn't it? But just leave it the way it is for now, okay? Just leave it like that. So I'm going to add that to this side and to that side. So I'm basically going to come here and going to put plus -6 over 2. What is -6 over 2, by the way? Does anybody know? -6 over 2. What is 6 over 2? 6 over 2 is 3. So actually, I'm going to simplify that. That looks very attractive. -6 over 3 is -6 over 2 is -3. And -3 squared is 9, right? So I'm going to keep that in mind, okay? So basically, I'm going to come here and say, in my case, I'm going to say this is plus 9. And where is that line here? Okay. Equals -2. And then, once again, I'm going to go back here and put the 9. So I filled the bucket with 9 on both sides. Let's see what's going to happen here. This is going to be 7 on this side, right? And on this side, if you looked closely here, you'll find out that you could actually come up with something being squared. For example, if you looked here, you're going to find out that you're squaring this x here. You are squaring this x here, like x times x is going to give you that amount. How about this dude here? Well, that's going to be a 3 times 3. Okay. So if you know just some basic math on this concept here, you will know that you are squaring something, which happens to be the x, and then you have a negative, and then you have yourself a 3. So it's x minus 3 squared. Basically, that's what I have. X minus 3 squared would give you this amount at the top here, x squared minus 6x plus 9, because you could multiply the first, and then 2 times first times second, 2 times the first one, which is x, times the second, which is 3, that's -6, and then you're gonna square the second, which is 9. If you're not sure what I'm talking about, it's perfectly fine. I was talking about a shortcut. But if you were able to factor this out, you will end up actually with x minus 3 twice. X minus 3 twice. Anyways, once you get there, you will have obviously to take the square root again, which we've done a few minutes ago, plus or minus. So now you have yourself x minus 3 equals plus or minus square root of 7, and then you add the 3, x equals 3 plus and minus square root of 7, which is again 2 solutions, and this is what I'm expecting to see, 2 solutions, since I have a quadratic. So what happens again in the completing the square method? Well, what happens in completing the square method is you are separating the c on the other side of the equation, and then you're going to take your b, divide that by 2, square it, put it in a bucket on this side, and obviously because of the equal sign you're going to have the same bucket on the other side. And once you do that, you're going to find yourself that you're looking at a perfect difference, a perfect square here of this item being squared and this item being whatever the item is being squared here, and you follow the sign in the middle here, by the way. So it's going to be whatever is squaring, use this sign, whatever is squaring this side, and that's going to give you the binomial that you're squaring. And then you take the square root of both sides. Okay. Not all of them are easy or are created equal because we have some ones that require more more attention in terms of I'm sorry, this was the same one that we just did with just some explanation with nicely written formatted answer. Okay, so you move to the other side, complete the square, divide the x, the coefficient of the x by 2, and then square it, add it to both sides, and that's what we've talked about a minute ago. Okay, not all of them are simple like this one. Sometimes when you add this bucket, it doesn't just give you a nice looking number like this. It might give you some weird fractions. That's what we're going to take a look at right now. So solve quadratic by completing the square. All right, show me. We've got 3x squared minus 4x minus 5. So the first thing for this thing to work by completing the square, remember when you complete the square, the a has to be 1, okay? A's gotta be 1. So in this case, what you do is actually divide by the a term because it's not 1 here. So a has to be 1. A has to be 1. Okay, that's the easiest way to do the completing the square. A has to be 1. Since it's not 1, you gotta divide by the a. Divide this by a. Divide this by a. Obviously, divide this by a as well. So if you are doing this and you are careful, you're gonna end up with x squared minus 4/3 of x minus 5 over 3 equals 0. Now you're back to the same concept that we talked about. You have an a here, which is 1. You have a b, which looks like a fraction here. We don't like it, but that's the reality here. You have a c, which is another fraction. That's okay. It's okay. Chill. So what you need to do here is, again, do the same procedure. You're going to separate that c. So let me change color. I'm going to separate the c. I'm going to add this 5/3 to both sides. So having done that, I'm going to end up with x squared minus 4 over 3x plus a bucket equals 5/3 plus a bucket. Remember, I added 5/3 to both sides. So how do I fill in the bucket? Well, Armani, come on, Armani. You make yourself room for growth and success. So I need the b over 2 squared. Oh, Armani, come on, this is a fraction. I know. So look at this one here. So what's the b now? I'm looking at negative 4/3. Sure, negative 4 over 3 divided by 2. You really have to read this very carefully, okay? Don't come up with weird things. So this is actually a negative 3 over 4 divided by, there's a big divided by 2. And let me see what's happening to my lines here. By 2, okay? So I'm going to take this very slow now. I'm going to say this is negative 4 over 3 divided by 2. I'm just basically doing this fraction here very slow. I want to find out what's going on here, which is negative 4 over 3 times, you flip this fraction. Remember, you flip the whole number, it becomes 1 over 2, right? Squared. That didn't change. And then you just multiply across numerator and then denominator. So that's a negative 4 over 6 square. Okay. And from there, I see myself looking at 16 over... Actually, you could simplify this further, because you could say the 4 over 6 could give you what? A 2 over 3? 2 over 3 squared. Okay. Now what is that? What is 2 over 3 squared? Well, 2 over 3 is 4 over 9. So just keep that in mind, okay? Just keep this value in mind. So I'm going to go up here and then use the negative 3 over 2 squared. I'm going to put that here. So it's going to be negative 2 over 3 squared. And also on the other side, it's going to be negative. By the way, when you square, it's not going to be negative anymore, right? When you square, it's going to be like this, because you're squaring this here. And that's going to be a positive here. Okay. Well, I made that positive. Let's go back and check. Okay, so I've got negative squared, negative squared, negative squared. So negative squared is actually negative times negative, which is positive. So we could have just did that all the way up here, because negative times itself twice is positive. So this is going to be positive, 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 all the way positive. So the value that you can end up with obviously is positive. Okay, negative times negative is positive. Anyways, back to here. So I'm going to put 2 over 3 squared. See that? So now in my mind again, there's something being squared here, which is x. X is being squared. What's being squared in this side here? What's being squared here in our money is that value itself. 2 over 3 times 2 over 3. There's 2 of them. And there's 2 x's here. And what did we say we could borrow from this guy? We could borrow the negative. So basically what you see here is one term, which is x minus, I just borrowed the negative from here. And then the second term, 2/3. That thing is being squared to give you this amount at the top. If you don't believe me, it's okay. Go to the warm-up and do this twice. You're going to multiply this by itself twice. You will end up with what you see at the top here. Okay. Anyways, this is going to be equal to the right side, which is a little bit awkward now, because now we have to really know what's going on. We have to split it out here. 5 over 3 plus the 2 over 3 squared, or if you guys remember the value that we came up with here, down here, 4 over 9. See that? So I'm going to go up here and then use that value, 4 over 9. Okay. That's 4 over 9. So I just have to play with the fraction a little bit here, because now I need to multiply this dude here by 3, right? I could multiply this by 3 to have a common denominator. So basically what I see on the left hand side is x minus 2/3 squared equals this amount here. And I said I could just do 3 and 3. That's going to give me a 15 over 9 plus 4 over 9. All right, let's keep going. Be patient here. And this means I've got myself x minus 2/3 squared equals 15 plus 4. That's a 19 over 9. And if I want to be careful again, I will take the square root of both sides. Of both what? Of both sides. Like this. I know we don't like it because of fraction. Trust me, I know how you feel now. I know. Just take it slow, okay? Take a deep breath. We can do this. X minus 2/3 will equal to plus and minus square root of 19 over 9. Now, it's going to be a weird combo here because I know there's something with the 9 I could do. Okay, I could play with the 9 because the square root of, here's my doodling side here, the square root of 19 over 9 is the same as square root of 19 over square root of 9. I know the square root of 9 is 3. So I could say this is the square root of 19 divided by 3. I could do that. So it's going to be x minus 2/3 equals plus and minus the square root of 19 over 3. Okay, I'm almost done. I'm almost done. I promise. I promise. So we're going to come here. Let's choose a different color. I like purple. So we add 2/3 to both sides, right? You're going to add 2/3 to both sides. So I'm going to go here again into my doodling area. I love the doodling area. And I'm going to add 2/3. I'm going to add that to plus square root of 19 over 3. Okay. Well, this is going to give me just that, or plus or minus, by the way. You could also say it's, I would just leave it the way it is, by the way. It's x equals, add the 2/3, plus or minus square root of 19 over 3. I do have a common denominator here. You could say also, if you want to be really facetious about this, you could say I have a common denominator here. Plus or minus 2 square root of 19. This also would work because you could separate them back into two separate fractions, or you could leave them nice and neat, intact, like this. Okay, so let me preview this since this was a laborious problem. What we started with was a quadratic equation. And this quadratic equation had this quadratic equation, oh my. This quadratic equation had 3x squared, so the a term was not 1. So it's a little bit laborious because you have to divide by the a term for you to complete the square. The a term, which is, I should say, the a coefficient, the number next to the x squared has to be 1. So in this case, you divide by that a. Everybody gets divided by that a. And you're probably going to end up with a fraction. And make sure that you have buckets on both sides. You do this carefully. Obviously, I've got a lot of doodles on the right side here, as you could tell. And then you would need to fill in these buckets by the b over 2 squared. And we looked at that multiple times here. And then we found out that you could, you actually know that this is being squared, which is the x is being squared. Also, this item is being squared, which is 2/3. And you borrow the middle sign here, which is negative. And we said if you're not too sure about that, how this become x minus 2/3, you go back to the warm-up and you will find out that actually these two multiplied together will give you this one on the top. So basically from here down is just basic fraction manipulation. So if you do not like fractions, well, here's your chance to flex these muscles and maybe start to develop some love for fractions. All right, champions. Okay, here it is, nicely formatted and printed. Okay, this should be it in a nice and printed way. All right. That's last solution. Also, I said you could have one fraction with plus and minus. Last but not least, the quadratic formula. This is the fourth method that we could use to solve quadratics, okay? Quadratic formula goes like this one. If you guys remember the ABC, okay? Don't forget the ABC, because next time you're going to sing with me. So for the quadratic formula, I would, obviously, that's not the first thing that you whoop out of your pocket and start paying for things just like a credit card, because it's going to cost you interest and stuff. So probably if you have choices, I would not use the quadratic formula right away unless if there is actually really need for it. If I could factor using the diamond, for example, or some other way, I would use it. But if you have to use a quadratic formula, it's okay. It's there for you. Anyways, for this to work, you really have to know your ABC once again. So quadratic formula goes like a minus b plus or minus square root of b squared minus 4ac divided by 2a. And I'm going to put it one more time here. What we're talking about is a x squared plus bx plus c equals 0. So you have to really know your ABC to do the quadratic formula. Okay? So let's take an example. Solve quadratics by using the quadratic formula. Okay, so I have x squared plus 3x minus 9 equals 0. Once again, I'm going to start labeling things. So I have a equals 1. I have b equals 3. And I have c equals negative 9. Okay, that's my ABC. What's the quadratic formula again? Come on, help me out here. So your x, the one that you're going to be looking at, is negative b plus or minus square root of b squared minus, come on, finish that up with me, minus 4ac divided by 2 a's. I think there's a song or something, a story, somebody came up with that just to memorize this thing. Anyways, x equals negative. What's my b in this case? Well, the b is 3. Plus or minus. What is my b? Armani, it's 3. Okay. Minus 4 times a. What's my a? That's the 1. Let me make sure this is 1, so we don't take it as not 1. 1. What is my c? Oh, it's negative 9. Okay. You're going to divide this whole entire thing by 2 times the a, which is 1. 2 times a. What's up with this one here? Okay. So x equals, excuse me, negative 3 plus or minus 9 minus, that's a negative 4 times negative. That's a positive, isn't it? Positive 36. 4 times 9. Divided by 2. Okay. So what is 36 plus 9? What is 36 plus 9? 36 plus 9 is going to be 45. So I have myself, where is that thing? Here. I have x equals negative 3 plus or minus square root of 45 divided by 2. Well, let's break the square root of 45 because I know there's something hidden there. Come on. You guys know that. Just give myself room here, like this. And then come and choose a different color for this work. Square root of 45. I'm going to break that again. You break it to its largest component. So you're looking for the biggest perfect square. It could be the 4, the 9, the 16. And it looks like I have a 9 here. I have a 9 times 5, which is square root of 9, square root of 5. Right? Let me fix this here. Square root of 9, square root of 5, which is 3 square root of 5. Sure, I could do that. So I will come here, and I'm just gonna, one more. I'm gonna fill in what I just know right now. Square root of 3. I'm sorry, it's 3 square root of 5 divided by 2. So that's basically going to be my answer for this problem. So what did we do for this quadratic formula? Well, Armani, what we did was, you've got to know the ABC for you to sing with us. So to sing with us, you've got to know the ABC. And the ABC are the A and B are the coefficients, A being the coefficient of the x squared and B is the coefficient of the x, C is just a constant. And I really have to know this formula here, which is the quadratic formula, negative b plus or minus square root of b squared minus 4ac divided by 2a. And I would just fill in the information. If there's any way for me to simplify the radicals, I need to do that. And that's what I did. And that is the answer. Okay, here it is in nicely formatted, printed version. Okay. This should conclude our discussion of the methods to solve quadratic equations. Obviously, there's a couple other ones, one of which is graphing, by the way. You could solve by graphing. When you graph and you touch the x-axis at certain points, which is a method I alluded to earlier. I did not dedicate time for it, but just showed you in the warm-up that you could have a solution by graphing, and you just observe where you're touching the x-axis. These are going to be the solutions, or the roots, or the zeros. And we did talk about solving by the quadratic formula. We talked about solving by completing the square. We talked about solving by the square root method. And then we talked about also solving the quadratic by factoring. Well, there's always hope, and we are not going to lose hope. As long as we have breath in our nostrils, we are going to be hopeful, because God takes care of all of us. Okay, guys, be blessed wherever you're at, and take care of yourselves. Have an awesome day.